All right, guys, we're rapidly approaching the end of chapter 3. I'm very excited about this, talking about inverse functions. This will be a challenge. Let's keep that open mind, that growth mindset. All right. Let's think about linear functions. Let's review some things. Let's review some concepts like, say, slope, right? Inputs and outputs. Important stuff. All right. These are things that we learned in Algebra 1, and here they are showing up again, so it's good to review. Slope, if we think about slope-intercept form, which looks like this, that's the slope right there, right? M. And it's the change in y over the change in x. Oh, I did. Also written as rise over run. So on a straight line, the slope is measuring how much did you go up versus over. Up versus over. It's basically tracking the rate of movement of your line. Inputs and outputs. X's and Y's. We've been working on function notation all month, really. So we have an understanding, right? Y, otherwise known as f of x, they're both outputs, right? So you plug in a number, you get another number. You plug in a number, you get another number. And it's the difference. Okay, I went from 2 to 3, I went from 1 to 2. So I went up 1, over 1, up 1, over 1. So I have a slope of 1. And hopefully this feels at least slightly, hopefully we remember this. So let's sketch this graph. I'm going to do this really quickly. All right. I know that this is the y-intercept. So when I make like a chart, right, I know that if I plug in 0, I get -2. And let's use like a different color for actually tracking it. I have a slope where I go down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2. That's a pretty quick way for me to find more points, right? 2, -3, 4, -4. Right? Let me confirm. Does this really actually produce this slope? Change in y over change in x. -1 over 2. Wow. Okay. So clearly what I'm doing is working, right? And I've got this great, um, I've got this equation, and now I've got the visual representation of it. I've got this line. Awesome. So now we get to talk about what does it mean to be an inverse. I typically ask, well, what does this word sound a lot like? Or where have you heard something like this before? People say things like, well, what about reverse or inverted, right? There's a great 80s movie out there called Top Gun where he flies the plane inverted to get close to another plane, right? Flips it upside down. All right, what does it mean to reverse things? What we're going to do to create an inverse function is you invert inputs and outputs. So instead of 0 leading to -2 and 2 leading to -3 and 4 leading to -4, instead the inverse would mean what type of equation has -4 produce 4, has -3 produce 2, has -2 produce 0. So an inverse of this function would be taking these points and instead of 0 to -2, -2 to 0. So the x and y switch places. What used to be the outputs are now the inputs. What used to be the inputs are now the outputs. So what does this look like? Negative 2, 0. 2, negative 3. Or sorry, I confused myself. I didn't even do it right here. Negative 3, 2. We keep going. Negative 4, 4. So a totally different looking line. That is the inverse here. We've swapped inputs and outputs. So what would we just did this, right? We're making a new graph where we're swapping x and y values. This is a great thing to maybe pause the video on and screenshot, right? Because this is really taking, okay, here's an original chart, 0, 6, 1, 4, 2, 2, 3, 0, 4, negative 2. What happened on the inverse relation? It's not 0, 6, it's 6, 0. It's not 1, 4, it's 4, 1. 2, 2 doesn't really change much, does it? What's cool about all inverse relations is that when your domain and range, your input and output swap, you always wind up reflecting over this line right here, y equals x, basically the original just diagonal line that runs right through the origin. Right? You wind up sort of reflecting, right? This reflected to here, this to here, this to here, this to here. This is also a great visual representation, and it introduces us to this notation. It's kind of interesting, but this actually does not mean to the negative first power. We actually use negative 1 to imply inverse. So when you see f of x versus when you see this, right? Notice how the negative 1 actually like goes after the f, right? If you saw something like this, maybe that might mean a function to the negative first power, but that's not what we're seeing. We're seeing it like this. This literally means inverse of f of x, right? And that brings us pretty much to the end here. We're going to do some practice. We're very early in this concept. So the goal is to really just practice taking a graph and flipping the point values, flipping the x and y. So we'll do some practice with that today. Hopefully this video helps.